In this video, I'm going to show you the first approach for implementing a stack in Python, which is going to be an array-based approach. In an array-based approach, we're going to store all of our stack values inside of an array, or in this case, a list for Python. We're then going to implement our push, pop, and peek methods over top of that array itself, giving us that last in, first out data access that we're looking for with a stack. The idea of this is that we're going to create a class named stack. And inside of this, I'm going to create my init method. And basically all this is going to do is it's going to initialize a stack as an empty array. What we're going to do is we're going to go through each of the different methods, starting with our push. Now, the first decision that we have to make for push is which end of the array are we going to consider to be the top of the stack. We could consider it to be the right-hand side, so the end of the list, or we could consider it to be the beginning of the list. And when we're considering this, we really want to consider how can we access the list in the fastest amount of time. We know that the stack or the list gives us the append method as well as the pop method, and both of these are amortized O of 1. So those seem to be probably the best choices for this particular process. So I'm going to go with that. We're going to say the end of the array is going to be the top of our stack. So for push, all we're going to do is we're going to take our stack and we're going to append to it the value that's being inserted. So on each push, the value gets appended to the end of our actual list. That's representing our stack, right? Now for pop, we need to be able to remove the value from the actual stack itself, right? There's a few things that we need to do before that, though. We first need to check to see if there's something that we can remove. So if the length of this stack is greater than 0. If it is greater than 0, then what I want to do is I want to return the value of self.stack.pop. This pop here is the pop method of the stack list. So don't confuse it with this pop method, right? This is the pop method of the list. What that will do is it will remove the last value from the actual stack itself. Now what happens if the length is not greater than 0? If the length isn't greater than 0, there's nothing on the actual stack. In that case, we would say that there is a problem of some sort, and usually we would raise an exception. So for this, I'm just going to say that I'll raise an exception, and the exception that I'll raise is going to be called a stack underflow, which means that we tried to remove from a stack that doesn't have any data on it, right? So that's the idea of our pop. Now our peek method is going to follow a pretty similar pattern to our pop method. We're going to say if the length of the stack is greater than 0, then I'm just going to return the value at the top of the stack, which we can do just like this. Otherwise, I'm going to, again, raise an exception to say that we tried to access the stack without any data on it. We'll call that a stack underflow. And you can feel free to customize these exceptions and customize what happens on this else. I'm just giving you an example of one thing that we could do here, right? Now, when we're looking at this, we can analyze these, right? We could say, okay, when I take a look at each of these different methods, I know that this one here is amortized O of 1, which is great. This one right here is generally going to be O of 1, and accessing at a negative index is also O of 1. So all of these are generally constant time, however, they're amortized constant time, right? So in some cases, we may have a bit of a longer runtime than constant time. And this amortized piece is really the main motivation of our second implementation that we'll look at, which is a linked implementation. But generally, this is a pretty good starting point, right? One final thing that I'll just note here, just for the sake of consistency between my data structures, is that I like to implement a size method. All the size method does in this case is it returns the length of self.stack. Now, you could just get the length of the stack property directly, right? This just makes it a bit more clear exactly what we're doing, that we're getting the actual size of the stack. And you'll see different preferences for this, right? Some people would just get the length of the actual property itself. Some people will do this size method. I just want to show this just for completeness so that you see this general idea, since I think it's probably the more common approach of the two. Now to finish off, let's actually do some stuff with our stack, right? So I'm going to create an instance of my stack, and I'm going to push some data onto it. So I'm going to push the value 1. Oops, sorry, I keep doing that. We'll push the value 2, and we'll push the value 3. And then what I want to do is I want to show you the result of running the peek operation. And then I want to show you the result of running the pop operation. And I'll run the pop operation 3 times just to show you. Now I want you, before you run this code, to think, what is going to happen with this code? what will the peak give you, and what will the pops give you. I'm expecting that the peak will give me 3, right? Because 3 was the last thing that was put on the stack, so it would be the first thing that we would see, right? I'm assuming that this pop will also give me 3, because that will remove the top of the stack and return it to us. After that's removed, the next pop would give me 2, and this one right here would give me 1. And if I were to pop again, I'd get an exception, which we'll take a look at as well. So let's see this one here first. When I run my code, you'll see that I'll get the exact result that I was expecting here, right? So we could see generally here that we have 3 as the peak, and then 3, 2, 1 as our pops, right? So that's what we're generally getting as our result. Now I'll just show you here as well that we can get an exception if I do another pop, right? So if I do another pop, the stack would be empty, and you'll see that I get this exception for a stack underflow. So this just gives you a bit more of an idea of how we can actually implement our stack. Like I said, this is one of 2 implementations. This one right here is our array-based implementation. And in the next video, we'll see an example of an implementation that's actually taking a look at a linked-based implementation, which is a bit more complicated, but gives us a bit more of an advantage of having control over the way that data is structured beyond having to use something built in like an array or list. So thanks so much for watching, and I'll see you in the next video.